This video is discussion 3.1b, which is all about naming ionic compounds. So the question for us to answer in this video is, how are binary ionic compounds named? Well, the general rule when naming ionic compounds is to name the cation first. And remember, the cation is the positive ion. This is typically the metal. And then you name the anion second. So you name the cation, which comes first in the formula, and then you name the anion. The anion is typically the nonmetal. But what you have to do with the anion is you change the ending to IDE. So you name the cation, then you name the anion, but you change the ending to IDE. The IDE with the anion tells us that it's a nonmetal from the periodic table. So an example would be CaO. So we name what comes first. Ca is calcium. Then we name O. So O is a nonmetal from the periodic table. So O is oxygen, but we have to change the ending. So it becomes calcium oxide. And that's all you do when you're naming compounds. So if we look at the next example, K3P. So again, you just name what comes first. K. K is potassium. Don't worry about the subscript down here. All we worry about is what comes first, what comes second. So potassium comes first, and then we have P. Use your periodic table. So P is phosphorus, but we have to change the ending, so it becomes potassium phosphide. Now, there's one variation when it comes to naming compounds, and one variation is the transition metal being your cation. So we have a transition metal with a nonmetal. And what we have to do when we name this compound is we name the cation first, and then we name the anion, change the ending to IDE. So just like before, except when we have the name of a transition metal, we have to include the charge in parentheses, because transition metals can have multiple charges, and so we need to know the charge of the transition metal in order to go backwards. So an example is FeCl3. So Fe is iron, Cl is chlorine, but we change the ending to IDE, so it's chloride. So we know that it's iron chloride, but we need to know the charge. Now when it comes to the charge, something that we can do is we can reverse crisscross. So we have a 3 down after Cl. Well, if we reverse crisscross up, that means that the iron, remember metals are always positive, iron would be +3. And so this would be iron 3 chloride. So just like before, except we have to know the charge of the transition metal in parentheses, because you should be able to go from either formula to name or name to formula. In order to go from name to formula, you need to know the charge of a transition metal. So then we look at the next example, PbO. Now we know Pb is lead, and lead can have multiple charges. Lead can be +2 or +4. And then we have O, and O is oxygen. Now we don't have any subscripts. Well, let's just use what we know about oxygen. We know that oxygen, if you look on the periodic table, oxygen forms a -2 charge as an ion, which means in order for this to overall be neutral, if this is -2, lead would have to be +2. So this becomes lead 2 oxide. So when it comes to naming ionic compounds, one variation is having a transition metal. The other variation is having a polyatomic ion. So instead of having a nonmetal at the end, we would have a polyatomic ion. And when it comes to naming ionic compounds with polyatomics, we name the cation first, just like before, and then you just name the polyatomic ion. You don't have to change the ending. So really all you're doing is you're looking at what comes first, what comes second. So if we look at the examples, Li2CO3. So think about, where's your metal? Metal always comes first. So in this case, I'm going to split this down the middle. Lithium is my metal. Then we need to look at our list of polyatomic ions and see what CO3 is. So we know that Li is lithium. If you look at your polyatomics for CO3, that's carbonate. So we would name this lithium carbonate. Because we can't change the ending, because the ending of polyatomic ions is what tells us that it's a polyatomic. So if we look at the next one, here we have Ba. That's a metal, so that's our cation. I'm going to split that down the middle. Remember, cation always comes first. So Ba is barium. Again, use your periodic table. Don't miss points for putting the wrong atom because you're not using your periodic table. So Ba is barium. And then we have NO2. Again, you don't worry about these other subscripts. All we worry about is what's the polyatomic. NO2. So look at your polyatomic sheet. NO2 is nitrite. So this becomes barium nitrite. And then the last one, NaCN. So just like before, Na is our metal. So that splits down the middle. Notice all of these are polyatomics, many atoms. So CO3, NO2, Cn, these are all polyatomics. So Na, sodium. Cn, if you look at your polyatomics, is cyanide. So this becomes sodium cyanide. So that's going through and naming ionic compounds. Remember that the only time that you have to have anything special in the name is if it's a transition metal. You need Roman numerals. And when it comes to polyatomics, you just need to know those 12 polyatomic ions so you can identify them.